Thank you all for being with us this morning. This is going to be a good discussion about 3D printing. How many of you would say that you were fairly knowledgeable about 3D printing before coming here? Some of us. We're going to kind of give you a good overview of it today, and we have a very distinguished panel to join us here. I'm Schrader from WRAL TV, do the traffic in the morning, and then report on all kinds of stuff for our other newscasts, and it's my pleasure to be here to moderate the panel today. We're going to talk with our panelists here and then open it up for questions that you might have. So let's start with Tushar. If you would introduce yourself. There's a microphone there. Pass it on down.
So, thanks for being here. I want to thank the staff members and faculty at NC State to begin with for saving me from all the trouble when I was here. I've been in the additive arena since the 1990s, mid-1990s, and currently with a local VC firm that I get from partners. Later on, with commercializing my ideas, with two startups, Elos MedTech and Optimium. Then started a non-profit as well called Fab Lab Carolinas. You're putting the group, goodness, they were very involved in supporting me with that particular initiative, and that's me.
Hey, welcome. I'm Rick Wysk. I'm on the faculty here, so I have the best job in the world. And I'm a person that has always tried to, quote, make stuff. So as somebody that makes stuff, I try to embrace some of the newest technologies and how things are being made. And one of those technologies is obviously this new method of additively producing those parts. So I'm trying to keep up with the technology. We're trying to do something that's very important, and that is make this technology profitable, meaning that if you've got a manufacturing technology, you should find something to make with it, and that should be a viable thing to make. So we're trying to find sort of the sweet spot for additive manufacturing.
My name is Ryan Bishop. I'm actually a recent graduate of NC State just this spring. I currently work for Touchstone 3D in Cary. We're a design and prototyping company. So we're real small, we're about 10 people. So we leverage our 3D printing capacity to help bring new innovative products to the market. And we like to make stuff as well.
Hi, I'm Johnathan Bissmeyer. I am a chartered quality for a company called Proto Labs for our 3D printing division. We are located in Cary as well. I've been with Proto Labs for about 3.5 years now, which in most industries would not be a long time, but the 3D printing industry is quite a bit of experience. We initially started as fine line prototyping, so people may know that name. We were acquired by Proto Labs about 2.5 years ago. Before that, my experience was with Honeywell Aerospace, and that's where I kind of got interested in the 3D printing realm, dealing with some additive suppliers. So, like I said, I enjoy it. It's interesting to come to work every day and see new things and see these technology advances. And sometimes you kind of not numb to it, but just don't realize what kind of cutting edge technology you are dealing with. And it's exciting when you just take a step back and talk about it to people and get that feeling again of how exciting it is.
Thank you again for being here. We think about 3D printing, you've seen it in the news, especially over the past few years. This is not a brand new thing. Tushar, the information that I have about you, it says that you helped set up one of the first 3D printing facilities in India in the mid-1990s.
Yes.
Would you take the microphone and talk about how it started, and for people maybe who don't know what 3D printing is, what are we talking about?
So 3D printing, I got the privilege to teach a class to undergraduates on 3D printing, and I told them we were going to do 3D printing. And what I did that day was help them build layer cake models. They would design something, then cut a piece of cake to the form, layer it to make the part. And that's what 3D printing is. It's been around for ages in different forms. Layer cakes have been around. With the semiconductor industry has been using something similar to 3D printing, where the chips actually have layers of things, layers of materials. What 3D printing is today is, or as it is perceived today, is deposition of material layer by layer to build a full part. Now, the advantage you get, I've got a nice little model sitting right here. I think I helped polish this thing 20 years ago. is it is blind to the complexity because you're just adding stuff layer by layer. And that's what it is. It's been around since the late 80s. Late 80s, early 90s, that's when it started picking up. And what we're seeing right now is a revival in the technology.
Dr. Wysk, what kind of materials is it creating as it deposits those layers? What can you use to build 3D models?
Well, at NC State, we use a whole bunch of materials. So my colleague Ola Harrison in the audience was one of the first to look at metals additive, and I think Tushar was part of the group that began the world of metals manufacturing. So 3D printing, when we see many of the images on television these days, one of the things that we normally look at is extruded wire, extruded plastics. And as we look at extruded plastics, we can see some complex parts coming to shape and being created. But we also now have, and I brought everybody on this panel, brings parts and has a little set of show and tell items. But it's being used now to create metals parts, and part of the venue for what NC State has been looking at is the application in the world of medical manufacturing, and in particular prosthetics, and creating something that's custom to a particular individual so that that person can get back many of the functions that they may have lost in traumas or through some type of disease. So we're working on a whole variety of polymers to metals.
This is about more than just building a fun model here. For this football, which is made out of titanium. Isn't that fascinating?
That's a Tom Brady proof.
There's no deflation. Something like this, the complexity of a 3D printed football made out of titanium. Ryan, what is the process for creating something like this?
So I think you mentioned something that's pretty important is the complexity. So if you look kind of closely at this ball, you can tell there's like a swirled, almost wrought iron looking piece in the center of it. And there's no other manufacturing process that can actually produce that form today. 3D printing is the only way you can actually produce that. So also the example right there is a good example of how complexity is, how 3D printing is aligned to complexity. So your cost will never increase if your part is more complex.
John, can you talk about what is the process here? You create a file in a computer of something, and then what happens?
So ultimately, back in the days of machining, I talk about like it was hundreds of years ago, but it was consistently 2D prints. You have a drawing, the tolerances called out, and the machinists would work off that and set the programs. Well, nowadays it's about digital manufacturing. They're calling it, basically Industrial Revolution 4.0. It's about the digital manufacturing. So everything's electronic. You use the 3D CAD model that's created, and for us at WRAL Labs, it's literally an upload. It's like you would upload any other file, and then we take that file that you upload, we pull it into our system, we support it depending on the necessary technology that you're using. And something like this, our technology is use powder bed fusion. It would support structures, and then load that file onto the machine that has support structures attached to it, and it's literally like Tushar said, is building it layer by layer. So it's spreading metal powder across this metal platform using a laser and welding that layer, then spreads a new layer of powder across and uses a laser and welds the next layer to it, and it just builds it up slowly by slowly, and it's pretty magnificent in its simplicity, but the complex features and parts that we can make is what makes it unique.
We have some of our panelists here represent businesses that are now in the 3D printing business. How common is it in our everyday lives now to use items that have been manufactured this way? Is it becoming more common, or is it still fairly rare?
For the everyday user, it's still fairly rare, and it's, I think it's been good for the industry. A lot of these desktop printers and ones that people can buy, they're selling at Home Depot for a while, but those are really used because a little bit of the material side, a little bit of the knowledge of the users, because there is some knowledge that people don't understand as far as supporting it and being able to finish the part once it comes off the machine. And so it's still rare on like an individual level, but a lot of the larger manufacturers, a lot of the larger customers and that we see, the GE is probably the most well-known in the industry for what they're doing in additive space. They're using it on a daily basis. I mean, they're putting it on stuff that individuals will start using on a daily basis, whether it be airplanes, whether it be cars. So it is making that progression, but it's not there yet, because I think the desktop 3D revolutions slowed people down a little bit in their understanding of it, just because they couldn't do some of the things they wanted to, but it's progressing on the industrial side, which is, I think, where people will finally get a better taste of it, and it'll kind of mature and people will understand it better.
I know over the past couple of years of covering these stories, we've talked about, one day you'll be able to just print up stuff in your home when you want to, replace a part in the refrigerator or whatever. How far are we away from that, Ryan?
I think the technology still has a ways to go. The materials, you can print some basic things, like maybe if you wanted a cup to put your pins in, but if you're trying to print something that's like a new bolt for your car, you may not be able to do that in your home, especially cost effectively right now.
Sure. We talked about this additive manufacturing as a term, as a concept. What does that mean?
Well, it's just rebranding for what used to be called rapid prototyping. 3D printing, additive manufacturing are the same things. 3D printing is actually a trademark term, so correct me if I'm mistaken, for a technology, a type of additive manufacturing technology developed out of MIT. It just became Xerox for additive manufacturing. Everybody started referring to additive manufacturing as 3D printing.
I think one of the advantages of having this technology is that it allows somebody that has an idea and skills to design it a chance to print it up, touch it, and hold it. How important is that in that prototyping process?
It's extremely important. So I was speaking to both the heads of GE and Ford Motors for additive manufacturing, and they tell me that within a week the systems are running at capacity for pretty much every single. We see our Ford 150s and the Focuses, but as one entity, but there's a design process that goes into it. There's an iterative process that goes into it. And they are extensively using 3D printing to make that happen. Ubiquitous with anything that's designed. Most likely this might was prototyped at some point and just see how it feels.
We talk about stuff like this, microphones, the biomedical applications. That's another part of this that may not be top of mind. Man, what opportunity there is there.
Wow. So
where are we going with that?
One of my startups was US Medtech, which was a biomedical startup in 3D printing. Now, there are interesting things happening at multiple levels. One is companies using 3D printing, the kind of machines that we have here at NC State, to build components which are very similar to what are being made. It's just economically more efficient. Then there are companies which are taking the big leap. Companies like Organo, which is taking a smaller big leap, where they're doing tissue engineering, but the tissue engineering is being done for the purpose of testing drug development, not as replacements. So instead of doing those in animals, then there's another company called Meadow, which is artificially creating leather or meats. There are all kinds of interesting things happening. Yeah. I think the next step in terms of barrier to entry to market would be a type of organs where a patient has trouble accepting donor organs. Think of them like organ disease. That will create an easier pathway for the tissue engineering 3D printing companies to get into that segment instead of just doing a ubiquitous organ replacement. Any type of kidney replacement, not that, but this specific patient can only accept this 1 in a million type of kidney. Then you can custom create that, and that will be the way to enter the market.
Dr. Wysk, what do you think?
The area in medical applications is really exploding. It's a lot of very interesting things. One of our colleagues yesterday gave a talk on printing of 3D tissue and was talking primarily about cartilage and chondrocyte expansion, trying to create, better models and better medical devices. So I've got a number of devices in front of me. Those are our hip replacements, they're hip stems. I got into the world of medical manufacturing at age 52 because I was the recipient of medical manufacturing where I had a hip replaced. And as you start using different technologies, you start trying to understand why you have them. But it's interesting to note the hip stem in the theater, the operating theater that I was part of, a X-ray was taken of my pelvis. There were no size specifications, but I'm about 5'8", weigh about 180 pounds, so I'm sort of the prototypical male candidate for this. But into the operating room, a device representative arrived with 3 candidate hip stems for me. And it wasn't until my buttocks was lanced and my hip was dislocated and sticking out a part of me that's not a very pretty picture that they decided to size that device for me. So there were 3 choices, and the orthopod and the medical representative said, I think this one should fit. So if we think about walking into a shoe store and looking and doing a eyeballing of, yeah, that looks like about my size, that's not the right time and the right place to do the kinds of things that we're talking about. We have the wherewithal to be able to scan our bodies using CT, MRI methodologies, come up with pretty exacting sizes. One of the major problems with some of the devices right now are something that's called aseptic loosening. And when we have these synthetic devices, they sort of pop out of place because they didn't fit quite right, and our biology then starts doing things like resorbing from those devices. And pretty soon you have a major medical, quote, revision, which starts becoming very, very expensive. So we really need to start looking at, 1, creating something that is made for individuals. It would also be nice to try to take some of their cells and maybe pre-populate those things. So as we're getting our hips or our knees replaced, we take some bone seeds and we seed these devices so that they start healing themselves before they actually enter our body. So it will make the process a lot more unique. It will make the recovery time much less. And there's an opportunity, if good industrial engineers get involved with it, the medical costs won't go up. The medical costs, in terms of the total cost, we won't need revisions, we won't need other kinds of remediation for things that didn't quite fit and didn't quite work right will bring down the costs associated with the application in this area. So that's something that we're really excited about at NC State. I think that there's a great opportunity in that arena.
And as you've heard from Dr. Wysk, NC State is really, and ISE is taking a big leadership role in this biomedical part of 3D printing. What is the university doing to advance this science and research? The best ways to go forward.
That's me.
Still let him arm wrestle.
Well, I'm not doing much of anything except spending a lot of time and talking, and people like Tushar are products of our program. NC State has provided probably the opportunity with laboratories which are unlike any other place in the country. We have the best set of metals additive machines of any place that I know of throughout the world. So as faculty members, as students of NC State, we have the opportunity to utilize these machines. The limits of opportunity are what our imaginations are. We're also blessed with having one of the best veterinary schools in the country as well, maybe in the world. And the opportunities that the animal research afford us. So I've got 2 dog hip stems here. So the opportunities that our veterinary school provides for us are absolutely limitless, and they're essential for this. And those of us that have been involved in medical manufacturing know that the way to get a product for human use is through a set of animal studies where we begin trying to create devices and seeing how animals respond to them before we move up to our human relatives here, and then we try to see what's going to happen to them. We like to find problems and maybe other deficiencies in a way that would be less harmful to a human population.
It sounds like this is another step here in the information age where we can customize so much, from these exacting specifications on clothing we order online to now you can get a hip 3D printed that will fit right in your socket right there. Is that what is happening here? Is that the future of the business part of this as well? Is that what's going to drive this forward? And I wanted an answer from everybody. We'll start to try and work our way back here.
So, eventually, but I wanted to add to something that Dr. Wysk talked about earlier regarding hip surgeries. Patients are benefiting. What he talked about is the patient benefiting, and maybe to some extent the doctor benefiting because the procedure is easier. In terms of introduction of technologies, we need to look at the 360 degrees around what's happening with something that's disrupted. So with 3D printing, the other thing that's happening is the hospitals don't need to carry the 3 sizes that you talked about. Hip surgeries are typically not a catastrophic event. Patients and the doctors know that they're going to have a hip surgery a month from now. So they can plan the whole process well in advance. Typical hip surgery, the kits which are used for the surgery, so it's not just the hip that is brought into the operation theater. It's an entire kit of tools that are brought in. That used to be the size of a suitcase. That suitcase has been reduced to the size of something a little bit bigger than one. So that makes things very interesting from that 360 degree point of view. So even if we start making those changes, it's going to have a huge impact on the market. I hope that.
I think that that's a great answer and a great observation. I think that we think about, I know I have 2 daughters that always say, Dad, I need the best and the nicest of apparel to fit my personality and my status. So we think about then ordering. Those of you that haven't looked at this, if you want to look at the Levi's website, you can specify your own size of trousers, which, I mean, my waist changes so quickly. They might fit when I bought them, and then the following day they were not going to quite fit as well. But I think that the hard portion of our bodies, we really want to acclimate. We want to do fit for that. I don't think that that fit is as important for some of the aesthetic kinds of things. So I do think that the world of medicine and getting things in place, and as Tushar so well pointed out, we're not going to have an inventory of hundreds or thousands of these things. It is going to be a pull-driven system where this whole thing starts with an MRI or a CT scan, and now our product begins being manufactured. So it's going to be one for one. So we're not going to have this large inventory. And I do think that if we approach this properly, we're going to be able to, for the first time in a long time, reduce the medical cost of doing things in this country. And that'll be a real benefit for us.
So I heard none. Where's the business going, Brian?
Okay. I'll make a note on customization. So I don't think we're very close to being able to customize and say this is exactly what I want, at least on the consumer level, because it requires an amount of design skill. So say I want to make a bracelet, I would have to design the bracelet, make a 3D model of the bracelet, and print it. So the printing is becoming easier because you can go to a company with a file and say, hey, make this for me. But I think, so what we're starting to see is websites like Thingiverse and GrabCAD, they start supplying CAD models for anyone to use freely. So there's going to be a much larger explosion of these CAD models available out there, and they'll come in different sizes, shapes, so that everyone can find exactly what they want, kind of on a customizable level. So I think we're moving towards it, but we're very close. We're not quite there yet.
Is it, when you talk about a website like that that offers a CAD model for a consumer at the consumer level to customize, that's a pretty significant barrier to entry for a layperson, isn't it? Or is that a problem that has to be solved?
I think it's fairly simple because you go there and you search for what you want, and you can look at it with a picture.
Mm-hmm.
Unless you're trying to find a mechanical component, in which case you probably have an entirely different skill set.
Jonathan, where do you see the business now and going in the next several years?
Now I think it's definitely the growth phase of the business. It's steadily growing. You see there's a lot of acquisitions occurring. GE, one fell through. They announced another one just yesterday of buying a machine manufacturer for metal, so they can use to produce machines and to produce the parts that they need for their commercial engines. So I think it's at extremely high growth rate right now. I think each part of the 3D industry is different. If you look at SL, I think it's mature. It's been around for 25 years. It's more of a matured state, and so it'll stay kind of steady state for a while. But I think metal and some of the other technologies are definitely at a high growth, and it might be another 5 or 10 years before those start to kind of plateau and level off and become that steady state. So I think it's growing, and I think something driving it. Talking about customization, but for us and a more industrial application, what we see a lot of times is the speed. It's people's obsession with speed. It's individuals, whether it be startups and wanting to get proof of concept, to companies wanting to do their iterative design. And so that speed is what drives their thirst for the 3D printing, and they're wanting to come to us because something that might have traditionally taken 16 weeks to get casted and have a lot of capital up front, they can get in literally 4 or 5 days. So I think that obsession with speed is driving a lot of this innovation and this acceptance of the technology and helping to drive the industry.
What's on your mind? You have some of the bright lights of 3D printing up here to answer your questions. What do you think? It's pretty amazing when you think about it. As Dr. Wysk said, the imagination is the limit. The technology is coming along to match up with what we can come up with to do with this
incredible technology, and NC State being a leader in it really puts us on the map in the triangle. Yes, ma'am.
So this question would be mostly for the businesses. Who are your customers right now? I mean, I can see later on it could be anybody, but who are your customers right now?
I'll start and then I'll hand off to you. Literally, right now for us, Pro Labs is, I mean, in the service bureau realm is what we say. We don't design, we make the parts for people. But our customers range from John Q. Public in his garage that has an idea of, I want to make something, I don't have the ability, but he has some CAD knowledge, so he can create that 3D CAD model and upload it to the largest corporations in the world buying parts for us for doing prototyping, for doing design iterations. So it runs the gamut from individuals to multi-billion-dollar corporations wanting to get these parts, and that's an everyday occurrence. You'll see a GE part sitting next to, like I said, John Q. Public's part, and it's a normal occurrence. It is on an everyday basis.
So I work a little bit on the opposite side of the spectrum. We're a product design company, so we work with people that don't have the skills to create their own CAD models. So typically our customers consist of just an average person with a sketch on a napkin that's their $1 million idea. So they typically bring it to us, and we handle the CAD work, and we leverage our 3D printers to rapidly test the design ideas to make sure everything works.
So, as a public servant, I work for the state of North Carolina. Has there been any discussions with, right here in Raleigh, most of the agencies are right here, any discussions or opportunity for adoption in government, particularly around transportation, agriculture? A lot of those industries really benefit from 3D printing. So I'm just curious about any collaboration opportunities you have.
There have been lots and lots of discussions. Some of the problems, in at least in terms of military applications, are qualification. The same is true of medical applications. This is a new technology. Tushar said 1986, I think, was the first sort of commercially available 3D machine. And as we start thinking about what quality of component is that going to be made, how good is it going to be, that becomes sort of problematic if it's going to be a military component or a medical component. But we're thinking about doing some other things. Good question. Both of those are really good questions. I was in Korea 2 weeks ago. So as I was sitting in Korea, and we were talking about Industry 4.0 and talking about the world of smart visualization in manufacturing. So that becomes interesting, and I was listening to Adidas talking about their new strategy. So as we start thinking, Adidas's new strategy for this is high-performance footwear is you come into the foot store, they scan your foot, they determine your exact foot size and specifications. You then determine the style of sole and the style of uppers, and these new sportswear shoes are going to be 3D printed. And I just thought to myself, that's an amazing sort of sight. There's a lot of pluses. There's no inventory. So there's no shoes that sit on the shelf in these odd sizes and so forth. But the materials that go into 3D printing, just the raw materials, are about an order of magnitude. They're 10 times more expensive as for conventional materials. The manufacturing time is also about 10 times greater for them. That's kind of a stretch, in my opinion, in terms of where we're going and the kinds of things that are going to be happening. But it would change. I mean, just think about that. You go into the store and there's a scanner and there's no product on the wall. You just fit yourself, as Ryan was talking about. You design your own shoes. You don't have to worry about anybody else taking the same shoes to the prom or whatever else, because they are explicitly yours. You're designing and you're creating every personal aspect of them. But I think that the cost of them is still going to be pretty pricey. But there's a lot of neatness in some of it.
So you asked about government programs. So I actually ran a nonprofit a few years ago called Fab Lab Carolinas, and we had support from different agencies. I don't think we had support from any government agencies, but the idea there was to go into underserved communities, both urban and rural, and take all these tools that we have here, not the metal 3D printers, but the lower end 3D printers, and put it right in the community and say, develop your ideas, try to commercialize it at a very grassroots level. And I think that's going to happen a lot more because the cost of executing something like that keeps going down. Right now, I think you could set it up for about $60,000. There was actually a bill in the Congress to set more of those facilities up. I think every 400,000 people population. Hasn't moved anywhere like everything else in the Congress. But shouldn't be talking politics here, right?
There is an election, right?
Coming up. But that idea has been thought of, it's been adopted elsewhere in the world. Interestingly, that idea came out of NSF, which is a federal organization, but they, people from other countries were more willing to accept it because customization there meant something in the sense that you don't have a Walmart where you can go buy something. So if you have an issue with, I'll give you an example. There was a shepherd in Norway, way up north in Norway. He would leave the sheep in the mountains during the winter and come back and then get ready to serve them. And it was difficult. So he came up with this idea of using 3D printing and a combination of sign cutters, just regular sign cutter to make copper or RFID tags for a sheep. So it's personalized solutions that they were creating elsewhere in the world. Surprisingly, it goes with National Science Foundation money, and we haven't done the same thing here. And what keeps that?
Well, I was going to touch more on your question as far as using like the technology as far as governments and organizations like that. We haven't done anything locally as far as making parts, but we have done something with other cities and county governments and things like that throughout the U.S. and maybe the world. I don't know the world what we've done as far as that much, but just making, whether it's, someone might have an idea on the maintenance side, if they're maintaining vehicles for government, whether Department of Transportation or something like that, they may have come up with an idea to help upkeep the maintenance on that, or replacement parts if it's an older plow or something like that. We have done stuff like that for governments. Nothing that I know of for like Wake County or the state of North Carolina, but that is something that is starting to slowly adopt it into those government agencies.
We talk about it all the time.
Yeah.
Just so you know,
Yeah.
I'm very interested.
So one additive manufacturing technology I can think of off the top of my head that would be helpful for government is printing of buildings. So I've seen there's been some work in printing in a concrete and fiber composite material where they have a giant rolling machine and it can print out the footprint of a house. So you can print it up and also include some airspace for insulation. So I think it could be very helpful for rural communities, and as well as 3D printing for rural areas. Instead of bringing hundreds of different materials, you could bring a few and then print exactly what you need.
You said in your role you'll talk about it all the time. May I ask what you discuss? What ideas have you come back?
I think for the most part, 'cause I'm a CIO, so it is always around technology, and so for the most part, trying to figure out what the right opportunity is, and even figuring out a pilot agency. But I think the biggest issue that we've got is who do we go to? Who do we talk to. So I know the CIO for agriculture here in the state has asked a lot, well, Tracy, can you please help us find someone that we can actually talk to, figure out what opportunities are out there that are available to assist them, because they understand the value of it. They've heard a lot about, in the biomedical field especially, and the cost savings associated with some of that too, with prosthetics and not having to keep buying it, but producing it for people as they grow. So I think for us, it's really about who do we talk to, who's the experts in this field, and what the opportunities would be. To your point around the transportation piece, that's huge.
Yeah.
There's a lot that goes into Department of Transportation, so that's another place where we're obviously very busy just like everybody else, but if we could find that right opportunity, and being an alumni, we do more work with the computer science area than we do with industrial engineering. So I would love at some point if we could find some type of partnership or engagement to look at a pilot or something like that and get it into state government so they can see the value of it and allow it to catch up from there.
So, jump in here. There are a bunch of agricultural incubators. And there are incubators just like technology incubators, which are there for agriculture throughout the state. And played around with the idea that there's someone who had this idea of currently you spray insecticides, herbicides, and I can't be using the right term now.
Yeah, you are.
You could use a roller instead, roller mechanism, because the insecticide just needs to be at the top, at the husk of the corn, for example. You have a roller applicator mechanism, but you need prototyping tools to do the proof of concept. So these kind of ideas are happening at these incubators. There was an urban farmer who had approached me about automating composting. And all these things, this is not necessarily 3D printing, but there's a bigger digital manufacturing / automation opportunity here, where you combine all these different tools where the costs are dropping sharply, the knowledge and the tools are becoming more accessible. It's not as if you don't need to be a computer programmer to make these things happen. And so using the combination of these technologies to enable what you're trying to do.
Be exciting to use that state capital synergy.
Right.
So.
Definitely.
Any other questions?
Yeah, I got a quick one. So how do we get so fortunate to have this kind of technology at our school? I mean, what was the precipitation? What was the germination? How did this happen? We could be so fortunate to have this type of cutting edge technology in Mississippi State, as opposed to pick another one.
Pick another one, anyone, right? But when did it become a focus here at NC State?
We're fortunate. I'm going to thank a colleague of ours who is very young, and as he was hired here, new faculty come with startups, so they have ideas, and you try to seed those ideas with a little bit of capital. So Ola Harrison, when he came, had some ideas about what were going to happen, and Ola has been a real leader in this particular area. So as he came aboard, he thought that e-beam technology, powder bed metals, was going to be something for the future, and that became something that needed. I mentioned yesterday we had a seminar from another colleague, Rohan Sriwaiker, and Rohan was talking about printing tissue using a bioplotter. I think that NC State has been, generous with new faculty and coming up with ways. I think our dean, Louis Martin Vega, who is also an industrial engineer, has been a real proponent of trying to seed these technologies and seed the people. We have excellent faculty, excellent students, and Tushar are products of our program. When you have great resources, the limits to what you can do with them are only limited to the time and the imagination of the people around the area. So I think our state has done a fairly good job promoting many of these things. I think that the other part of all of this is, I think that the industrial engineering faculty are very open to talk with anybody. So anybody that's in the audience out there, in terms of both government, industry, I think that we give more tours of our laboratories and facilities than any place I have ever seen. So we're always, trying to do our mission work, and our mission work is educating some of the people of North Carolina, in particular the people that are in businesses, to show them new technologies and potential applications for what's happening.
Thank you all so much for being here today. I want to thank our panelists as well, and happy homecoming, right?